Hi, my name is Kim Kenny with the Crewe Astronomy Club, and welcome to the first of 5 lessons in getting started in the exciting hobby of astronomy. Since 1998, the Crewe Astronomy Club, or CAC, has been putting on astronomy programs at Virginia State parks, and we're always asked the same basic questions by people who are interested in getting started with exploring the night sky, or just buying their first telescope. Now these 5 lessons, each 10 to 15 minutes long, cover the basics, so after all 5 lessons, you should feel pretty confident exploring the night sky or buying your first telescope. Now these lessons should also enhance your experience if you have already downloaded some of the available astronomy applications for computers, tablets, and smartphones. Now Lesson 1 covers finding the planets and the ecliptic. Lesson 2 is how to explore the moon. Lesson 3 is deep sky objects and the Messier catalog. Lesson 4 covers using a planisphere and telescopes part 1, and Lesson 5 is telescopes part 2. Although you can watch this on your smartphone, your best experience will be viewed on a tablet or computer monitor so you can see the constellations more clearly when we explore large sections of the night sky. So sit back and let's get started. Well, the questions asked by most beginner astronomers are, how do I get started? That is a common question. Where do I look? And do I need to buy a telescope first? I don't want to waste money. Another question that gets often asked. How much power do I need? And any chance, though, to go outside and get with friends and family is always fun because it's a great family hobby. And astronomy is a great family hobby because when you go outside and when you look through a telescope or binoculars, you can have rewards on your very first night out. You never know what you're going to see up in the night sky, but once it gets nice and good and dark on a moonless night and something might just fly by, might be a meteor, might be the International Space Station, something to share with your friends and families for weeks or months or maybe even years to come. So a lot of people ask, they want to see the planets, the moon, nebula, star clusters, and galaxies. Well, that's actually 3 types of astronomy. So first, we'll show you how to locate the planets from your own backyard. So the first is called planetary astronomy. Now in planetary astronomy, the first thing you have to remember is that all the planets are moving at different speeds around the solar system. Mercury clocks in at 110,000 miles an hour. Venus averages a speed of around 78,000 miles an hour. We're traveling on the planet Earth at an average speed of 68,000 miles an hour, and the moon travels around us at 2,300 miles an hour. Mars, 58,000, and then we have the 2 big gas giants which we can visually see with our eyes, Jupiter at 28,000 and Saturn at 20,500. But there is a simple way to find them, a very simple way to find all these planets up in the night sky from your own backyard. So the planets will be in a straight line, and this straight line is called the ecliptic. We see the planets by this oval, but from our perspective, all those orbits are tied together just like this as you see, and they're all in a straight row. So since the planets are in a row called the ecliptic, Mercury, Venus, Mars, Jupiter, and Saturn can be easily seen without the use of a telescope. They will look like very bright stars up in the night sky. So if you're looking east just before sunrise, you might catch 2 bright objects next to the moon. The planets will appear in a fairly straight line from east to west where the sun and moon rises and sets. Looking west just after sunset, there's Jupiter traveling along with the moon, setting towards the west. There's that beautiful ecliptic line. This is where they're all following. So the sun, moon, and all the planets will follow the same path. Now the ecliptic line will vary throughout the year due to the Earth's axis tilt. So on our longest day of the year, the ecliptic path looks like this, around June 20th. Our shortest day of the year looks like this, around December 20th. Quite a difference, and the ecliptic path is going to vary between these 2 extremes throughout the year. So here in Crewe, Virginia, you can see right here we're noted by the little yellow dot, but we're rotating in this direction, as you can see. So as we rotate, you can see where that extra light comes from. So on our shortest day of the year, the sun is actually setting in the southwest, and our longest day of the year, the sun is actually setting to our northwest. So quite a big difference between those 2 looking at the same horizon. So to find the planets, all you have to do, just take your hand and draw a line between the sun and the moon. Where the sun rises and sets across the sky, the planets will follow the same path. So as we rotate, you can see where the sun is just set. Your second point of reference is the moon. This is where all the planets are going to be. Where the sun rises and sets, the moon rises and sets, that's where your planets are going to be. Now, a phased moon always points to where the sun is before sunrise and sunset. So if you get up in the early morning and you don't really know where the sun exactly is, well, the moon will be a dead giveaway to find where the sun is. As you can see, the sun's coming up because it's always shining on that one side of the moon, looking towards the east. Of course, we're further along on the other side, so it may not have gotten light yet. Here on the west, if you look towards the west after the sun is set, if the sun is completely gone and all the light's gone, you still know that's where the sun is. That's your first point. The second point is the moon. That's your ecliptic going right up and around. So here's Venus and Mercury at sunset before stars begin to appear. There's the sun setting, the two planets, and that beautiful ecliptic line cutting right across the night sky. Looking overhead a couple years ago, Mercury, Venus, and Mars at sunset. There's your ecliptic line. Notice how different it is from the longest and shortest day, but still basically going from east to west. But even though we see the three planets just like this, from outer space, it would look like this. Now I'm going to enlarge the planets here just a little bit so we can see them better. We're on planet Earth, which is blue. Then there's Mercury, Venus, and Mars. But from where we are now, on the third planet from the sun, the blue planet, now we see, as the sun starts to set, there's Mercury, Venus, and Mars. There's the orbit of Mercury, the orbit of Venus, and the orbit of Mars, going up and around us because it's the fourth planet. The first two, of course, are ahead of it. From our perspective, looks like this: Mars, Venus, and Mercury, right there in a perfect row that you can see. And there's that ecliptic line. All those orbital paths combine into one thick line that follow the sun and the moon as they travel across the night sky. Well, another clue finding planets within the ecliptic line is that stars twinkle and planets don't. That's right, they reflect light from the sun. So the planets will appear, though, about 20 minutes before stars begin to appear and remain visible after stars have faded before sunrise. So the planets will be the first objects to appear and basically the last to leave outside of the sun and the moon. The twinkling is due to Earth's atmosphere. Stars emit their own light. They travel great distances, light years away, of course, and as the light travels through our atmosphere, the stars appear to twinkle. Planets are very close to us and reflect light from the sun. So here in this example here's the sun and the moon going right across. You got your 2 points of reference. You know where the sun is, you know where the moon is, and in your mind, you draw that ecliptic line going right across the sky. So aim your telescope at all the bright objects within the ecliptic line, and you'll notice, well, that's not really a star, that's actually Saturn. There's stars in Gemini, the moon close up, Aldebaran in the constellation Taurus, and Jupiter. So to see any planetary detail like this, you will need to buy a telescope between $100 and $200. That's kind of a given. And we'll tell you about power, around 200 power to look at those things. So here's Venus and Mars. Right when it starts getting dark, you'll notice this is where the planets really come out. Venus especially, and Mars when it's in opposition. We'll tell you about that in just a few moments. But notice how red Mars was when it's in opposition. Just absolutely beautiful. 1 hour before sunrise, there's the ecliptic line going right across. There's Saturn, Mars, and Jupiter on the right. If we wait now about 20 minutes before sunrise, now we see most of the stars have all disappeared. You can see a few, but look how pretty those planets are still showing up, right in that beautiful arc going through the moon. 1 month later, here are the same three planets. As you can see, they've separated due to their different speeds around the solar system. So in this case, we waited about 30 minutes before sunrise. A few more stars appearing in the night sky as you can see the sun reflecting off the clouds. But notice, there's all three planets, 1, 2, 3, as they travel along with the moon along that ecliptic. So that's how easy it is to find the planets. Viewing the planets is a lot of fun. Now, viewing Mercury, that's more of a challenge than anything else because Mercury is very small and close to the sun. So we only see it as a dot against a blue background. Never really gets totally dark when viewing Mercury. So when we add the orbit of Mercury, to give you an example, Mercury travels around the sun in 88 days. So in 44 days, it's on the opposite side of the sun. So in between the red lines, we can't see a thing. So let's put the Earth there instead so you can really see what we get to view for about 10 days evening viewing and 10 days morning viewing. And that's all you're going to see. Venus, on the other hand, this is what we call viewing phasing Venus. Now with Venus, you actually get to see a lot of beautiful phases, just like the moon. So when Venus is behind the sun, you see this beautiful orange little yellow dot. But now as Venus travels over the sun, it's twice as big, twice as bright, and now you see a quarter Venus when it's over the sun. But now Venus, remember, traveling 78,000 miles an hour in front of the sun and traveling past the Earth. So low on the horizon, in front of the sun, a nice crescent Venus, twice as big, twice as bright, and gorgeous to look at through a telescope. So Venus is also called your morning star, visible in the east. When it's on the other side of the sun, it's called your evening star, visible only in the west. So 1 year for Venus is 225 Earth days. So as Venus loops around, it's going to rise and set in the east and rise and set in the west. So from our perspective, we're going to add the Earth here. This is what we actually get to see as Venus goes around, rising in the east for several months and then setting back. And then we don't see it for a while behind the sun, and then rising in the west and setting in the west. So this is what we actually get to see, a nice crescent Venus, a quarter Venus, and a full Venus. Wait a couple of months, a nice full Venus, a nice quarter Venus, and a nice crescent Venus, just like that. So how wonderful it is to look at this planet, and it's a lot of fun to look at. Some people even mistake it for looking at the moon when we have it really close. Mars, on the other hand, viewing Mars, we get to see Mars every other year. When Mars is behind the sun, we really don't get to see a whole lot the majority of the time. 80% of the time we don't get to see Mars very well, only 1/3 the size of Earth. So if I add the orbit of Earth and Mars, it's around 215 million miles or more as it's on the back side of its orbit. So our view through a telescope is just a fuzzy red dot most of the time. So this is what we call viewing Mars in opposition. Because to view Mars in opposition, this is where we get to catch up to Mars. Remember, we're traveling on planet Earth at 68,000 miles an hour, Mars around 58,000 miles an hour. So every hour we gain on it 10,000 miles. So 687 days for Mars to go around the sun. So we will catch up to it. This is when we want to view Mars right here. Yeah, this is opposition. So now we've shaved off a couple of million miles. So now we're only approximately 45 million miles away. So through a telescope, now we get to see detail. We get to see the polar caps on a really good clear night and all sorts of detail. And of course, the little dust lanes, or what they call canals. Jupiter and Saturn, great views every year in opposition. 365 days the Earth goes around, but of course for Jupiter and Saturn, their time much longer. So 12 years for Jupiter to go around the Sun, and 29.5 years for Saturn to go around the Sun. So a recap on planetary observing, and that is you can only see planetary detail on Venus, Mars, Jupiter, Saturn, and the Moon. Mercury, you're not going to see any detail, just a nice white dot against a blue background. Venus phases and is yellow, just a nice orange-yellow dot behind the sun, over the sun, and then a crescent when it passes in front of the sun. Mars, you can only see detail every other year when it's in opposition, as we just discussed. Jupiter, on the other hand, you can see every year in opposition, and in a telescope around 200 power, you get to see this image along with the jewel of the universe, Saturn. Uranus and Neptune you can't see with your naked eye, but when you spot it in a telescope, a little green dot and a little blue dot, but no real planetary detail. So you can see those 4 planets, and the 5th planet that we love to observe is our own moon. So that'll be lesson 2 on lunar astronomy. I'm Kim Kenny, and on behalf of the Crewe Astronomy Club, clear skies, and thank you for watching.